What happens if you travel faster than light? Imagine you're standing at the starting line of a race. The gun goes off and you sprint as fast as you can, but no matter how hard you try, you just can't outrun the other racers. Now, imagine the fastest racer isn't a person, but something far more powerful: light. Light is the fastest thing in the universe, and it travels at an incredible speed of about 186,000 miles per second, 300,000 kilometers per second. That's fast enough to travel around the Earth 7.5 times in just 1 second. But what if somehow you could go even faster than light? What would happen? This is one of the biggest what ifs in science, and it's something that scientists, thinkers, and even science fiction writers have been wondering about for a long time. To understand the possibilities, we need to break things down into a few important pieces, starting with something called the speed limit of the universe. The universe's speed limit, why you can't go faster than light. Think of light speed like the ultimate speed limit, like how there are speed limits on roads. On the highway, cars aren't allowed to go faster than a certain speed because it's dangerous. Similarly, in the universe, nothing is allowed to move faster than the speed of light because of how physics works. The rules of physics, which explain how everything in the universe behaves, say that nothing with mass, anything that isn't light, can break this speed limit. Why is that? Well, according to a famous scientist named Albert Einstein and his theory of relativity, the faster something moves, the heavier it gets. So if you were able to move faster and faster, you'd also get heavier and heavier. By the time you reach the speed of light, you'd be infinitely heavy, which would require an infinite amount of energy to keep moving. And that's just not possible. No matter how hard you try, you'd never have enough energy to reach light speed, let alone go faster. But what if, for a moment, we imagine that you could go faster than light? What would the consequences be? Time travel. Could you go back in time? One of the wildest ideas about faster than light travel is that it might allow you to travel backward in time. Imagine you're in a spaceship flying at the speed of light. In theory, time would slow down for you. The faster you go, the slower time moves. This is called time dilation. If you were to somehow travel faster than light, some scientists believe time could move backward. You could leave home, fly off at faster than light speed, and arrive back before you even left. Sounds strange, right? But time travel isn't as simple as hopping in a faster than light spaceship and going wherever you want. The laws of physics might prevent this from ever happening, even though it's fun to think about. For now, time travel remains more of an idea we see in movies rather than something possible in real life. Breaking the rules, causality. Here's where things get even trickier. There's something in science called causality. It's the idea that everything happens in a specific order, cause and effect. For example, if you drop a glass, the glass falls and then breaks. The falling is the cause and the breaking is the effect. But if you could travel faster than light, this order might get mixed up. You could break the glass before it falls. Doesn't make sense, right? That's one of the reasons faster than light travel causes so many problems in physics. It breaks the natural order of things. Space and time, what are they? Before we dive deeper, let's quickly explain what space and time are. Space is everything around you, where you live, where the planets and stars are, and where the universe exists. Time is how we measure things moving and changing. Einstein realized that space and time are linked together into something called space-time. When you move through space, you're also moving through time, and they both change depending on how fast you're going. The faster you move through space, the slower you experience time. This is why astronauts who move really fast in space experience time just a little bit slower than people on Earth. It's not enough to notice, but the difference is there. Warp drives and wormholes, science fiction or science fact? In science fiction, you might have heard of spaceships with warp drives or wormholes. These are ways to cheat the speed of light without actually going faster than light. Warp drive. Imagine you're sitting on a rug, and instead of running across the room, you pull the rug toward you. A warp drive works in a similar way. It moves the space around you instead of you moving through space. In theory, this would let you get from one place to another much faster than the speed of light, without actually breaking the speed limit. While scientists have thought about warp drives, we don't know how to make one yet. Wormholes. A wormhole is like a shortcut through space. Instead of traveling the long way from one side of the universe to the other, you'd go through a tunnel that connects two faraway places. This could allow for faster-than-light travel, but wormholes are still just a theory. We don't know if they really exist or if they're possible to create. Tachyons, faster-than-light particles. Some scientists have imagined particles that might already be moving faster than light. These particles are called tachyons. Unlike normal matter, which gets heavier as it goes faster, tachyons would actually get lighter the faster they move. If tachyons exist, they might always travel faster than light. However, we haven't found any evidence that tachyons are real, so for now, they remain a fun idea rather than a scientific fact. The consequences of faster-than-light travel. Let's say somehow you manage to travel faster than light. Here are some things that might happen. Time dilation. Time would slow down for you, or even reverse, depending on how fast you were going. You could potentially age much slower than the people you left behind. Causality problems. Events might happen out of order. You could arrive somewhere before you even left, which breaks the basic rules of cause and effect. Energy requirements. As mentioned earlier, you'd need an infinite amount of energy to move faster than light. This makes it nearly impossible to achieve with our current understanding of science. Strange physics. Our current laws of physics might not apply anymore. We don't fully understand what happens at faster-than-light speeds, so all kinds of strange things could occur. Could we ever travel faster than light? As exciting as it is to think about, faster-than-light travel remains out of reach for now. Our understanding of physics tells us that nothing with mass can travel that fast. However, science is always changing and evolving. What we believe is impossible today might become possible in the future. Just like people once thought it was impossible to fly in airplanes or travel to the moon, faster-than-light travel might one day be within our grasp if we find a way to change the rules of the universe. Final thoughts. While the idea of traveling faster than light is thrilling and opens up possibilities like time travel and exploring distant galaxies, it comes with many challenges. Physics tells us that light speed is the ultimate speed limit, and trying to go beyond it creates problems with energy, time, and the very rules that govern the universe. But don't let that stop your imagination. Many of the world's greatest discoveries started with someone asking, "What if?" And who knows? Maybe someday we'll find a way to reach the stars faster than the speed of light. Until then, we'll keep exploring the universe one step or light beam at a time.